Preamble. Among the most significant advancements from leading artificial intelligence companies in recent months, a noticeable and consequential trend has crystallized. A definitive inflection point has been reached. What was, until relatively recently, considered experimental is now rapidly becoming established infrastructure. Artificial intelligence is evolving into the primary interface layer through which individuals and organizations interact with technology and, increasingly, with the world itself. The recent Google I/O 2026 event provided perhaps the clearest institutional signal yet that AI is no longer a feature set appended to existing systems. It is, in the most architecturally precise sense of the term, becoming an operating system for everyday life. This is not a metaphor to be taken lightly. For those working at the intersection of technology architecture, enterprise software development, and digital transformation, IT consultants, computer scientists, program developers, and content creators among them, the implications are structural, strategic, and immediate. From feature to foundation. The trajectory of artificial intelligence within the consumer and enterprise technology stack has followed a recognizable pattern. For the better part of a decade, AI capabilities were delivered as discrete enhancements, a recommendation engine here, a natural language search interface there, an automated classifier embedded within an existing workflow. These features were additive. The underlying architecture, the operating system, the application layer, the user interface paradigm, remained fundamentally unchanged. That paradigm is now shifting at a pace that demands serious analytical attention. At Google I/O 2026, CEO Sundar Pichai framed the moment with notable directness. Speaking from the Shoreline Amphitheater in Mountain View, he acknowledged that the industry has entered a phase in which stakeholders expect to see genuine value in the products they use every day. 10 years since Google pivoted to an AI-first orientation, the company's announcements at this year's conference reflected not a continuation of that pivot but its completion. The company did not merely present AI as an enhancement to its existing product portfolio. It presented AI as the organizing principle of that portfolio, the substrate upon which everything else is built. The evidence was observable across every major announcement at the event. Google introduced Gemini 3.5 Flash, described as the first in a series of models combining frontier intelligence with action, alongside new voice capabilities embedded directly into Gmail, Docs, and Keep. The conference also introduced Gemini Spark, a newly designed small model, alongside Gemini Omni, Anti-Gravity 2.0, and a universal cart capability aimed at agentic commerce. Across each of these announcements, the consistent architectural theme was the same: intelligence is no longer a layer on top of the interface. It is the interface. The agentic transition. For practitioners in software architecture and enterprise systems, the most consequential development to emerge from the current AI landscape is not any single model release or product feature. It is the shift from AI as a tool to AI as an agent. This distinction carries significant technical and organizational weight. A tool responds to explicit instruction. An agent pursues goals. A tool operates within defined parameters. An agent orchestrates workflows, manages resources, and, crucially, makes decisions. By 2026, AI agents will no longer sit at the edges of applications as optional features. They sit at the center of the software ecosystem, orchestrating workflows in a manner that is more characteristic of an operating system than of a utility. This characterization merits unpacking. A conventional operating system does not perform tasks in the manner a user-facing application does. Rather, it manages the conditions under which all other tasks are performed. It allocates resources, mediates between hardware and software, enforces security boundaries, and provides a consistent runtime environment for everything that operates within it. When analysts and architects speak of AI becoming an operating system, what they are observing is the emergence of AI as precisely this kind of foundational, mediating layer, one that sits between the user and the broader digital ecosystem and through which all meaningful interaction is increasingly channeled. The enterprise data supports this reading. Gartner has reported that 72% of enterprises plan to deploy AI agents or copilots by 2026, with Microsoft projecting that AI agents will come to be regarded as team members with dedicated responsibilities. Furthermore, enterprise adoption of autonomous AI has surged, with more than 240% growth in agent-based automation across sectors reported by Gartner, as organizations recognize that the only scalable means of managing complexity is through systems that can adapt to it. Implications for the developer ecosystem. For program developers, this transition carries immediate and practical consequences for how software is conceived, designed, and delivered. The conventional model of software development has been fundamentally procedural. The developer defines logic, specifies conditions, and prescribes the sequence of operations that a system will execute. The developer, in this paradigm, is the author of explicit instruction sets. The emerging model displaces this paradigm in important respects. In 2026, developers do not build step-by-step task logic. They build the tools that agents use to accomplish goals, API endpoints, data interfaces, execution environments, cloud functions, and guardrails. Developers become the architects of possibility rather than enforcers of prescribed logic. This is a substantive redefinition of the developer's role, and it brings with it both opportunity and complexity. On the opportunity side, AI-mediated systems offer the prospect of software that is genuinely adaptive, capable of handling edge cases, managing ambiguity, and improving over time in ways that statically defined logic cannot. On the complexity side, the shift introduces new classes of challenge around observability, determinism, and accountability. When a system's behavior is driven by a large language model or an agentic framework rather than explicit conditional logic, the traditional tools of debugging, testing, and audit trail management must be substantially reconsidered. Google's announcement of Anti-Gravity 2.0 at I/O 2026, including its zero-config observability capability, represents one institutional attempt to address these challenges precisely, eliminating the need for teams to build custom monitoring pipelines for AI workloads and reducing the DevOps cost of managing such environments. This is instructive. The infrastructure required to support AI-native architectures is itself becoming a product category, which underscores how foundational the underlying shift is. The interface revolution. Beyond the architectural and development implications, there is a consequential shift, like the human-computer interface, that technologists and content creators alike must account for. Emerging AI operating system concepts aim to create computing experiences in which natural language becomes the primary interface, eliminating traditional application paradigms. This is a departure of considerable significance. The graphical user interface. The window, icon, menu, and pointer model that has defined personal computing for 4 decades, was itself a radical simplification of the command line paradigm that preceded it. The AI-mediated interface represents an equivalent order disruption. For content creators, the implications are nuanced. On one hand, AI-mediated interfaces lower the barrier to content production, enabling individuals without specialist technical skills to generate, edit, and distribute sophisticated material. On the other hand, the same infrastructure raises substantive questions about authorship, attribution, and the provenance of content. Google's expansion of SynthID digital watermarking and C2PA content credentials at I/O 2026, aimed at helping users identify AI-generated media, reflects the industry's acknowledgement that these questions are not merely theoretical. They are operational concerns that must be addressed at the infrastructure level. For IT consultants advising clients on technology adoption and digital strategy, the interface transition presents a challenge of change management as much as one of technical implementation. Organizations that have invested substantially in workflow automation, enterprise application portfolios, and user training programs built around conventional interface paradigms must now account for the possibility that those paradigms will be substantially disrupted within a relatively short planning horizon. The market trajectory. The commercial and economic signals reinforcing this technological trajectory are unambiguous. The AI in operating systems market is forecast to grow at a compound annual growth rate of 19%, with projections indicating a valuation of $42.6 billion by 2031, up from $17.7 billion in 2026. This growth is being driven by multiple converging forces. At the infrastructure layer, a significant technological shift is occurring from cloud-based AI processing to NPU-accelerated on-device inference, which crucially decreases latency and enables AI-mediated experiences that are responsive in real time. At the enterprise layer, the productivity case for AI-native systems is being made with increasing rigor. IDC data from 2025 indicates that users lost an average of 42 hours annually dealing with slowdowns, freezes, updates, and system troubleshooting, precisely the category of friction that adaptive, AI-managed system environments are designed to eliminate. Strategic considerations for practitioners. Given the foregoing, what are the concrete strategic considerations that practitioners, IT consultants, computer scientists, program developers, and content creators should be actively addressing? First, the architectural assumptions underlying current system designs must be interrogated. Systems designed on the premise that AI is a supplementary feature layer require re-evaluation. The relevant question is no longer how to integrate AI capabilities into an existing architecture, but rather how to design architectures that are AI native from inception. Second, the skill profiles required for effective participation in this ecosystem are evolving. Fluency with agentic frameworks, prompt engineering at the systems level, and the governance of non-deterministic system behavior are competencies that will increasingly differentiate effective practitioners from those working with obsolete tooling. Third, the governance and accountability frameworks within organizations must be updated to reflect the agentic nature of AI systems. When AI agents are making consequential decisions, managing workflows, initiating transactions, communicating on behalf of users or organizations, the question of accountability requires explicit and documented answers. This is not a theoretical concern. It is a compliance and risk management imperative. Fourth, and perhaps most critically, practitioners must resist the temptation to frame the current moment as merely another technology cycle. The shift from AI as feature to AI as infrastructure is structurally different from previous technology transitions. It is not additive in the way that the adoption of cloud computing or mobile platforms was additive. It is, rather, a displacement of the foundational interface layer through which all other technology is experienced. Conclusion. The announcements made at Google I/O 2026 are significant not because of any single product or capability. They are significant because of what they collectively signal. That the leading organizations in the global technology industry have, after years of incremental progress, committed institutionally to AI as the primary organizing principle of the digital environment. AI is no longer a novelty feature. It is becoming an orchestrator, the connective tissue that sits behind and between the tools, platforms, and workflows through which digital work is conducted. For those whose professional responsibilities require them to design, build, advise upon, or create content for that digital environment, this is not a development to be monitored from a distance. It is the operating context within which all professional work in this domain will henceforth be conducted. The experimental phase has ended. The architectural phase has begun. Those who understand the distinction will be positioned to shape what comes next. Those who do not will find themselves designing for a paradigm that no longer exists.
This essay has been produced by Terome Technology. Until next time, bye.